Welcome back to the Security Journey podcast. My name is Michael Birch. I am your host, and today I'm joined with Phillip Maddux. He is a deception technology expert, and that's going to be the focus of our conversation today, deception technology. But before we dive into that, as I always like to start, Phillip, what has been your security journey? How have you come to become kind of an SME in deception technology?
My security journey feels like a long way. It has been a long one, but I mean, just going back to early days, just obviously always interested in computers. Then finally getting my own computer, just hacking away at things, learning whatever I can. And then as I kind of got into college, I landed my first role, starting to do web development, system administration, database administration. So really just learning and absorbing everything I could about ITT. I like to say I had ITT or IT ADD. I was just into everything. And that kind of drew me towards, obviously being kind of intrigued by the hacking and security issues that were evolving at the time. That kind of drew me into learning more about security, especially kind of having that broad base. It felt like it was the one thing that would keep me interested as far as having to have your hands in all different technology and knowing what's going on. So I started pursuing studies in security to kind of formalize that. Obviously, I did a lot of self-taught things along the way. So eventually getting a master's degree in information assurance sounds very sophisticated. But and then I actually with that I landed a role at a university as being the IT auditor. And so that was kind of my first sort of role with kind of active security responsibilities, like reviewing and auditing for security. It was interesting because never done audit before, wasn't trained in it, but it was the office of the audit was looking for someone that had the IT background and the technology background that they could teach the audit process to. And so that just was a great fit. So it worked out really well. So then that eventually led me to focusing more on application security. So I got a job actually focused on application security. So and then application security really became the majority of my career for several roles in several different companies. But along those lines, through studies or what have you, had learned about honeypots and was always intrigued by honeypots, and it was always kind of a side thing for me. So always dabbling with what tools were available and so on and so forth. And that actually led to where I was trying to build my own kind of honeypot network, so to speak, but the tools were limited, and so there came a point where I wanted a better honeypot that did the things that I wanted to do, but at the same time, I also wanted to learn Python. So I put those two problems together, and I started writing my own honeypot, and so that's kind of like the genesis of my focus in honeypots on the side of doing application security. Um, so that actually evolved into a project that's out there now called HoneyDB. So it's at honeydb.io. And so it's basically there's a honeypot agent that you can download and deploy, and then it can sit, and then the website will centrally collect all that information that's coming from the honeypots. So it's basically intended to be kind of like a community-driven honeypot data aggregation platform, so to speak. So that's kind of the where I got into the honeypot space, when leading into the whole concept of deception. Over the years, honeypots has kind of evolved to this term of deception. And so I was actually kind of, with what I had built, a lot of colleagues were encouraging me to kind of make a commercial version of it. And so I pursued that, and that's what is now Deception Logic. So that's a kind of enterprise ready service or to deploy honeypots, and also it gets into the concept of deception tokens, which we can talk about later. But so that's where that evolved, and just kind of application security career. with an itch for engineering and focused in the honeypot space. So I think that's the summary of me.
So it's I find actually this really interesting. It's really cool to actually talk about this because when I was growing up in the security courses, one of the ways that I gained a lot of my security background is I actually took a bunch of SANS boot camps. I had the military that kind of segued me to basically pay for my SANS boot camp. So that's where a lot of my education came from. But that's actually the first time I heard about deception technology. Honeypot DB was one of the things that we were taught about, and one of those first projects that we were used to describe how honeypots work. So that was actually part of one of my foundational curriculums of learning about deception technologies was that project.
Oh, that's awesome. Yeah. Yeah, I mean so I mean just to kind of jump into talking about the space of honeypots a little bit further is it's a space that's been it's a concept that's been around for a long time, but I've seen that just over the years it's never kind of gotten traction in enterprises for deployments. Now there are some environments that are more mature, and so they've kind of got all their baseline controls in place, and so now they're looking for how else can they extend their defense in depth, and so they'll start to look at that stuff. But I think we're seeing more and more companies reach that maturity point where they're starting to explore what they can do with the concept of honeypots and deception. So it's kind of starting to become less of a kind of an academic kind of concept that's talked about but never productionized. But I think it's becoming more now something that's productionized.
In your company right now, the one you work that's commercialized this, what's the kind of main thing you're doing there with that?
Yeah, so basically we have deception services that you can deploy, and the real kind of, I guess, the goal behind it, and it goes along with the tagline that we have, which is make your network dangerous. And that's really about being able to take this capability and deploy it everywhere throughout your network. So you make it dangerous for the attacker, right? Someone comes in your network, they're going to stumble onto one of these honeypots and expose themselves. So there's certainly that concept that can be applied at the network services layer, but we're also focused on deception tokens. So that's where we get into the concept of making files basically become triggers to an extent when they're accessed to alert and expose an intruder. So those are, but the kind of key to it all, I think, to get the traction, and so it just makes it easier for a security organization to say, okay, we can take this on, is ease of deployment, ease of management, automation. So trying to really solve that, to really grease the wheels to where it becomes, hey, we could do this without requiring a lot of overhead and resources.
I think that's the biggest key of, especially where we're at in the space right now for security, is there's a lot of great technology out there, but if it's work, and I'm actually still something my CEO kind of brings up all the time, if it's work, it won't get done. You need to automate it, right? It needs to be seamless. If it's work, if I have to manually go in and set up every little thing and do every little piece of it, it ends up falling to the side, especially in the security realm.
Yeah, and that's key, right? And I think it's also because, security teams are strapped resource wise, right? And for time. And so they've got, lots of fires going on, and, a lot of tools and controls they need to implement and convince people to implement and things like that. So but they definitely want, they want to get to the point where they can start doing the more in-depth sophisticated capabilities as far as detections and so on and so forth. So like I said, the key is enabling them to do it without requiring a lot of their time. So yeah.
All right, well, I think this is a great time to segue into our main topic. But before we jump in, we're going to take a quick 30-second break, hear from our sponsors. Then we'll come back. We'll jump into the conversation of deception technology.
The Security Champions podcast is brought to you by Security Journey. Train your development teams with engaging secure coding lessons developed to address both common and novel application threats. Security Journey offers the most flexible training plans that can use data from your appsec testing tools to identify and train on vulnerabilities in your own code. Visit securityjourney.com to try our training today.
Welcome back to the Security Champion podcast. I'm here joined with Phillip Maddux. He is an SME with deception technology, and that is the topic of the day. We're going to talk about how we can leverage deception technology to do a better defense. So let's talk about what is this technology? What is the point of deception technology? How do we define this?
Yeah, so, and I think there's probably going to be, different folks out there might define it different ways, but the way I define it is kind of like in three columns, right? You have one, some type of sensor, a detection, something that triggers an alert, right? Now, a simple example of that is like a honeypot, right? So it emulates a service that no one should ever interact with. And so if someone does interact with it, that becomes a high fidelity alert, and it's something that you should respond to, right? Like it's something worth spending your time responding to. So that's really the essence of it, right? So to basically trigger, to be there on the environment and trigger an alert if depending on how you deploy it, if there's an intruder in your network, right? Like if they get past your controls, your detection controls or your preventative controls, you kind of have this as almost like a backstop to potentially detect and cause the intruder to expose himself. So you have some type of sensor, we'll say. The other component of it is like what they refer to are lures, right? So these are things that you can put in your environment that will lead the attacker to the sensor to trigger the alert, right? So the space gets interesting because you can be really creative. There's no on how you do this and how you implement lures. So there's a bit of an art to it. But yeah, that's the second piece, right? It's out there. So it could be as simple as, say on an endpoint desktop, you have a text file that has, HR FTP server is the name of the file. And in that file is an IP address and some credentials, right? But that IP address would lead that intruder to a honeypot sensor, right? So that lured them to the honeypot sensor, and now they're exposed because they attempted to connect to it. And then the third column, I say is automation. So it's about just automating the deployment, the implementation, configuration, and also the response as well. So those are the three columns, we'll say, that I and how I describe what deception is about and what it is. But yeah, and so I'll just to add to echo again that it's about getting that high fidelity alert. But I think there's also some use cases where you can use it where I refer to it as to generate targeted threat intelligence.
I like the idea of the high fidelity too, because the idea of it is that this technology, we're putting it somewhere that 100% nobody should be. You shouldn't be here. You shouldn't be using that credential we gave you. You shouldn't be hitting that IP address. It might be somewhere within our DMZ or our secure network. It's somewhere you shouldn't be touching. So if someone touches that is a 100% positive. That's an alert and it's real. Versus we have a lot of tools out there that have a lot of noise. And that's what makes a lot of, I think, security tools very hard to manage, is the amount of noise that you have to sift through to get actionable data. Deception technology definitely hits at the home of this is always going to be some sort of actionable. At least it's going to let you know something's happening.
Yeah, exactly. And I mean, you're also going to have the cases, and this is where, having the right system in place and process around it is important. Because obviously, yes, no one should touch this component on your network, which is a honeypot. But you may have vulnerability scanners that scan your network, right? So you need to be able to handle that, right? Like you don't want to generate alerts on vulnerability scanners. So you need to have the right integration there. But I've had folks tell me, but this is actually interesting because I can deploy this in like the dark corners of my network, and I can validate that my vulnerability scanner is reaching it. And so it's kind of the flip side to that. But yeah, there's different ways to kind of take advantage of it.
That's interesting. Actually, I don't think I've ever heard of that type of use case, which I have an uncle that's in network engineering, and he builds a bunch of devices that help you let you know your network's alive and that all the pieces can actually talk to each other. If something goes down, it lets you know. It's almost that same application. It's like you can put this in places you need to be reaching. If you're not reaching, there's a problem. That's kind of It's a definitely different use case than I've heard in the past for using this technology.
Yeah.
With the honeypots, right? So these are ideas. Can be entire architectures, right? I've heard these like as simple or as complex as, and it looks like you're an entire network of systems. Because one of the ways I've heard this talked about is I love to waste people's time, right? Like if you're going to be like wasting my time, right? For me having to hunt you down or trying to cause me damage, the more time of yours I can waste, it can A, I'm wasting your time, that's better for me. And then B, it keeps you around longer on something you don't need to be doing versus something you might be doing that's harmful, right? What's kind of your experience with that? How complex like the best case scenario for setting up these type of honeypots can be?
Yeah, so in general, across the board, like with solutions, I always like a nice, simple, elegant solution, right? Like something that's not too complex. I feel like simple can be just as effective, if not more effective. So, so there's different tiers of interaction for honeypots. So you can describe them as low, medium, and high. So low could be something as simple as just a port listener, right? Like you can't interact with it, you can't do anything with it. But if you connect to the port, an alert fires. Or, it could just be a banner, right? Like you connect to the port's FTP port, and then it just gives you, the banner from the FTP service. But you might get a prompt for username and password, but you can't really, you can try to enter stuff, but you're not going to log in. You're not going to get access to anything on the system. And then there's medium. So that's where you start to give a little bit more interaction. So maybe you give credentials and you do log into an SSH server or FTP service. And then you have access to look around and maybe, touch files, and do things like that. But that would be, I would say that those levels, low and medium, would be emulated, right? Emulated services. So you're not actually interacting with the OS itself. It's a contained, controlled environment that's emulated. And so that at the same time gives you, a bit less risk to operate something like this. So, which may be important to a lot of folks to not have to worry about if their honeypot's going to go sideways if someone hacks it. So when you get into high interaction honeypots, that's where you might see where the services you connect to and get access to are the actual services on the OS, so like a telnet service, right? And so you're interacting with the actual OS. So in those scenarios, you have to really make sure if you're deploying those, you have to make sure they're instrumented correctly and contained correctly, so you don't get a breakout or anything like that. So more involved, more risk to operate, but obviously, depending on what your goals are, that might be something you want to pursue, and that would be more of kind of like intelligence gathering, like really just like you want to wait and see and collect what they're doing. In a very real environment way. But again, you have to have a lot of, isolation and instrumentation around it to do that successfully.
So it's funny, I have to pull the security guy back in me, right? Because part of me is like right off the bat, like I want to see everything they're doing. Let me set up this crazy architecture and let's just watch them, right? Now, for the day-to-day organization, that's probably not what we actually need to be using this technology for then, right? More high fidelity alerts, less risk, definitely seems more organizationally appropriately versus the Mike that wants to be like literally sitting there like, I want to know exactly what you were trying to do in my network and watch you, right?
Yeah, exactly. I mean, if you got a DoD research grant and you got the time to go build all that out and spend the time on that, then, go at it. But yeah, I think for most enterprises, the most important thing will be that high fidelity alert, right? Like I want to know if we have a situation that we need to respond to. Now, I think as organizations start to get into the space and implement it and mature their program in this space, so maybe they're going with medium and they might reach a point where they say, well, we want to start to learn more about what these attackers are trying to do. You can still do that with, I'll say, the medium interaction, right? You just have more sophisticated emulation with the, known possibility that the attacker could discover that, oh, I'm in some kind of fake environment. So they'll pack up and get out of there. But by then you've already got the alert, you're already on it, and so you kind of achieve the goal as far as detecting that intruder. And
we have this other concept, right? So with honeypots, how does that differ than what you were talking about earlier with these tokens?
Yeah, so I guess you could say, so I said honeypots is some type of sensor, right? So that could be a network service, but it could also be a file, right? So these tokens that they're referred to, so I refer to them as deception tokens. So these would be files that you put in your environment. So on file servers, Google Drive, just wherever you have file stores where you're concerned about someone getting unauthorized access to. And so those sit there, and then when they're actually opened, and in some cases just accessed in any way, they will trigger an alert. So you'll basically get an alert. This file was opened, and so now you know that you can go and investigate. So just a common or simple use case of that would be Google Drive, right? So if there's a file on a user's drive that someone accesses, and that's one of the deception tokens, then that potentially could mean that user's account has been compromised, right? Someone's gotten control of the account, and now they're just trolling through their drive to try to see what data is there.
That's the interesting part too. One of the thoughts that, like, when I first heard about this technology, that one of the first things is it's a great alert to know when people are coming into my system, right? But I almost, like, one of the harder threats I think we ever have dealing with is people that have authorized access, that are already inside our environment, that are insider threats. When they start doing things they're not supposed to do, we don't have a lot of good systems that are great at capturing that, because they have authorization, they have access. Seeing when they do something wrong is a little bit more difficult, or something they shouldn't be doing. Have you ever seen that as a big kind of use case for this, being able to detect those insider type threats?
Yeah, absolutely. Insider threat is another use case for this, definitely. So you could think, you have an easy example is, an HR drive, and then you have, their files there, but then you put 2025 layoffs file in there, right? So obviously that's going to be interesting to folks that shouldn't be poking around there. And so if they access that file, you get the information about that, the alert and the information, and then you can go and investigate to determine whether that was appropriate or not, right? So it's definitely, even from a network service standpoint, right? Someone that might be, internally, maybe they're just, they downloaded Nmap and they're curious about it and they're having fun, but they shouldn't be doing that. Or someone that might be, looking to do something nefarious with the access that they have, right, to access systems. So all of that makes sense from an insider threat perspective. Yeah.
What's funny is you bring up the Nmap thing, and it seems so trivial, but it probably happens way more than people would like to acknowledge. I remember the first time I took a class about Nmap, I downloaded. Everyone was immediately like, "Don't scan random networks. You will get in trouble. You don't have authorization to test their networks," right? So my caveat, if anyone who doesn't know what Nmap is and you want to go download it, there's your caveat. Do not scan other people's networks you don't have permission to scan. But that's interesting, right? You'd be able to detect, like, hey, it might even be a super nefarious thing. It might be like, hey, sir, you're not allowed to scan your own networks. That's not authorized within our organization. We need to retrain you a little bit here.
Right. Or why did our endpoint controls not detect that you had Nmap?
Yeah, that's another big one right there.
Right.
One of the other things I kind of bring out to this, I like I said, the idea of, I get this image in my head when I start picturing these out, because what I always like is like these layers of onions we start putting within our security environment. And we have our firewalls, we have our access control points to allow people in and out. But then, like, once we start getting within internal security, theoretically, everyone has this zero trust architecture, right? The idea that you're automatically locked out by default, maybe not as practical or implemented in real practice, and that's why one of the number one things the attackers can do when they get access is they can pivot to go somewhere else, right? Because we just leave everything open once you get in. But I love this picture of having these layers of deception technology, like, integrated throughout my onion, at the edges, the closer within, to the tokens hidden throughout my environment. Because it becomes this kind of like, it's a landmine, right? It's not like nefarious, it's not going to damage anything, but now I can collect a lot more in-depth and like technology, or not technology, information about my own network. Even like you were saying there, when we have it set up so when I scan a network, if I have all these tokens and other honeypots and things set out throughout, when I run a scan, they can probably give me even more high fidelity information for what's happening within my own network, right? Yeah. So my question, I guess, is to you: is with organizations you've seen and work with this and stuff like that, have we hit a maturity level where people are getting up to that level, or where they're really getting these high fidelity like ingrown networks, or are we still kind of in the precipice where people are just testing this out?
No, there's definitely organizations that are seeing success, as far as what they're getting out of deploying deception technology for sure. And it's one quick note. It's interesting because to try to prove value for this type of tool, it can be tricky, right? Because you could deploy it and 3 years later nothing happened, and you're kind of like, well, is it really worth it? And then well, which is why I'll say it needs to be easy to manage and like lightweight for the security team. But then 3 years, day one, you get a hit, and oh my gosh, you've just detected a breach, right? So then all of a sudden it's like we want more. We want more of this, right? So it's that kind of thing where it's like, until you get that hit, you kind of are skeptical of the value. But I know organizations that have not got hits, but they love knowing that it's there, right? And you mentioned the zero trust, right? And so that's actually another interesting use case because with zero trust and the whole work from home movement, right? You've now extended your network to people's home networks, right? And which has who knows what on their home network, exposing them to all sorts of things. So I guess with attackers are you move that zero trust to their endpoints, they become the target, right? So home networks are now vectors into enterprise networks. If they get control of the endpoint, they have access to keys to access the zero trust tunnel, and move on from there. So I think it's definitely an interesting use case to even deploy this capability on your employee's laptop, corporate controlled employee laptop at home, because then you can get telemetry on potentially what badness is happening in their house or in their home network, and that can at least give you a little insight to like, hey, maybe we need to educate our employees on secure practices at home with their networks, but also gives you those alerts in case something does happen as far as a breach on that endpoint.
Yeah, I love the thing that you bring up is that proving ROI. I live in the security training space, right? I fight that every day. It's like, how do you prove that I trained you and you prevented vulnerability? Well, when you do it right, you shouldn't see anything. So after everyone's doing it right, how do I prove that I got you to do right? It's only when something goes wrong do you prove the value, or could have prevented is the theoretical value, right? So ROI and security can be really finicky sometimes. But yeah, I think that goes back to seamless, right? As long as it's seamless, it becomes a much less, it gets reviewed less for people to decide, oh, this isn't valuable, and then they get rid of something, and all of a sudden they get attacked, or they get hit by something or do something wrong. Ethical stuff. So this is another part. When I first learned about this technology, have you ever heard of the debate between venom versus poison?
Refresh me, clarify that for me.
So let me clarify what that means. When I was first taught about deception tokens, these are alerts, right? Honeypot alerts. There was a concept brought up the idea of like, okay, are you allowed to attack back when you get an alert, right? And obviously, ethically, no, you shouldn't attack back. There's a whole lot of reasons you shouldn't attack back. One of those reasons you shouldn't attack back is it might not be the person that's attacking you that you're thinking is. People use other organizations or their pivot from other places to make it look like they're attacking from places they're not. So attacking back could be very harmful. And I don't think it's legal in any circumstance. But that attack back is the idea of venom, right? I'm going to inject my venom back at you. You attacked my network, so I'm going to come back and we'll attack your network, right? Poison, though, is where things get a little interesting, right? There's this concept that, well, what if I had a honeypot or a fake infrastructure, and in there I left something that would damage your system if you downloaded it and took it away from my system. So it's like a zip bomb that you can't open on my server. So if you pull it and download it on yours, it zip bombs on your computer and I take your system down, right? That's where I would say things get in kind of the ethical gray of this like attack. Now, understand deception technology, that's definitely not necessarily geared towards attacking back or leaving out venom. But it comes into that whole realm of conversation of I'm putting things throughout my network that now is going to deceive you one way or another.
Yeah. Yeah, no, I could definitely see where, you might want to apply that. But yeah, I agree that we wouldn't want to do that attack back scenario or attempt to damage their environment. And I think if you do that to the wrong person, that might just make them more angry, and they might come back and do more damage than what they would have originally, right? Because who knows how much access they have currently when that occurs. But I would say where I think it makes sense to do something is more information collection, right? So, for example, we have these deception tokens that could be in an HTML file or whether it's from a file system or just kind of like an unlinked to file or endpoint on your website, but it has JavaScript that can do more information collection about the client that has pulled it down, right? Like no one should access this file. Someone's loaded it. We've got some JavaScript that's going to collect more information from that environment. So, potentially that could do some kind of enumeration and other things like that.
Well, I think that's great too, right? It's obviously a much more ethical way to approach the thing. We definitely don't want to be causing damage in places that we don't control, and damage in general. Let's be defensive, not offensive, right? That's our goals here in life. But as we go through that information collecting, that's massively valuable, right? If you steal a bunch of data from me, and in this you catch a token, and I can collect a bunch of data back on you, that's going to definitely help for my investigation. Even if it doesn't give me the final answer, it gives me another piece of information as I'm putting together all this story of trying to figure out that incident response, right? That's quite often what incident response is pulling together a story of all the little things we can figure out what happened. So definitely interesting use case to be able to collect more data in that type of moment.
Yeah, exactly. And it's and I'll say that with the deception tokens, there's a variety of kinds and how it could be implemented, and that could also, depending on the implementation, could limit the amount of information you get back to understand what the source. So it could just be an IP address, or it could be an IP address and a user agent string, and things like that. So if you're able to collect more information, that's all the more you have to determine attribution and potentially obviously the source and where it's coming from.
Another interesting, I think, string to pull on, right? We're going to go theoreticals here. We're in an age of AI, right? We're in the age of how do you integrate AI into everything? So I got to ask you, all right, now we're in deception technology. What are some thoughts of does AI have a space in this? Like, does that have something that could potentially be added in the future? I guess it more pulls on the question of what's deception technology look in 5 years, right? Well, what could be the future of this?
Yeah, a couple of different things there. So AI, yeah. So it's interesting because I've seen some things come out in the industry, related to honeypots and AI, specifically around kind of AI generating responses, right? So you just tell AI, emulate a telnet service, right? Someone connects to it and it starts interacting with it. Right now I'm a little bit skeptical of that. I feel like it's interesting, but I don't think it scales very well. And also I've seen there's research recently on basically doing timing responses to determine whether it is AI driving a honeypot, so on and so forth. So I don't know if we're there yet. We're kind of AI. You just tell AI be my honeypot, and it goes and does it in a realistic way. I don't think we're quite there yet. Where I see it makes more sense to apply AI, there's a couple of different ways I look to apply it. One is, okay, so we're creating deception tokens, right? And so let's say you have you want to deploy a deception confluence space, right, in Pages. And well, okay, that's cool. We could do that, but what do I put in those pages? It's like, well, I got to become a writer. Well, AI is perfect for that. Right. So you can describe what you want these pages to be. You could say, have fake, secrets in them or something like that. And so AI is really, really great at generating that type of content for deception. Right. So, and then you can use that to deploy out. And then I think another area is, interpreting the analysis of the data coming in. Right. So, I mentioned before there's, concept of targeted threat intelligence, where that can be a lot. That's not high fidelity alerts. That's like a lot of telemetry coming in, or potentially a lot of telemetry coming in. So to have AI to be able to summarize that data for you and give you a good kind of picture of what's going on instead of you kind of going into the details and trying to decipher all the things that are going on. So I think that's at least the first step into AI in this space. Another area which I think is a great concept and haven't implemented yet, but it's like, one of those backlog items. But to be able to feed AI a picture of your environment and then say, okay, draft a deployment strategy for deception for me, and then hook that to automation to go ahead and deploy it, right? So I think that's a great concept and something I'm definitely going to be pursuing. So yeah, those are great places for AI. But and then you asked about where's deception going. I'll pause here in case you had comments on the AI, but I'll touch that other topic in a
No, what's funny is if you didn't drill in that second point, that was definitely a thing I was gonna bring up. Like, how about like deciding where to put this stuff within my architecture? Like, that's another one of those use AI where it makes sense type tasks, right? AI can't do everything for us, it shouldn't, but there's definitely things that it can make easier for us, and that's definitely one of the ones I definitely could see being a use case in this tech.
Yeah. And then so the other thing you were asking about was where is deception going, I guess, in 5 years or what have you. I like to say that like the world is moving to a point where enterprises, when they expose their services, it's all over port 443. So effectively what I'm saying is the application port. So like kind of everything's going cloud based, right? So traditional network services might be getting abstracted away. And so really everything becomes application layer. So then the question is, how do you start to do and implement deception in the application layer? And that's where kind of this is where the art comes in and creativity comes in. And there's definitely a few concepts there that we've kind of been teasing out, and we're going to be proving out more things. But it's definitely an area that I think is. I mean, it's really where deception's got to go, right? It's got to get to that application layer.
See, what's interesting on that is like when I think about stuff like that, I think of stuff like I asked, right? And if anyone's unfamiliar with what I asked is, it's the like next level of DAS that when you like compile your application, it puts a bunch of little listening agents throughout the application at different points, and then when it attacks it, it can get more information about what's actually getting hit. Versus traditional DAS is you just launch a bunch of attacks and you're waiting to see if something breaks, slows down, or you get some response. You don't have nearly the insight on the inside of the application. So I definitely think of that like as the application's being deployed or built out, or even like the pipeline, what areas can deception technology go there? Pipeline's another big one, right? With supply chain attacks, like that is the topic of the year, right? And so things that like where could this technology live across the supply chain to let us know when things go wrong or are different? That's another interesting idea.
Yeah, transparently, I haven't put a lot of thought in that from a deception standpoint, but that is interesting. But yeah, going back to the application layer though. But yeah, I mean, I think there's a handful of concepts that can be, and just like some basic stuff that can be implemented there. I mean, just to start out, right? Like it's you have like a robots.txt file on your application or your site, right? Web-based application. So that might have some deny entries in there that should never, be visited or crawled. And so if you have, fake responses to those, then that can give you, information that someone's accessing these endpoints that, no one should be accessing. So that's like a very simple example. But yeah, I think the challenge, I think that kind of needs to be addressed or solved is, from a security team perspective, how do I integrate deception into the application without bothering the developers, right? And also, kind of fighting that battle of like, convincing, the development management that this is okay to do, right? So there's some friction there where I think, again, back to creativity, how do we solve that, and how do we do it in a way where it doesn't disrupt development?
Yeah, that is an anthem I sing quite often. Whenever we're specifically development, right? Because that's who we teach here at Security Journey. Anytime we get in the way, we'll eventually be bypassed or forgotten. So you need to make sure it's seamless.
Yeah, absolutely.
All right, well, Philip, I think we're kind of coming to close the conversation. Is there anything else on this topic that we didn't touch that you think you would just be great to let the audience know, or touch on?
Yeah, no, I think we covered pretty good ground. I guess the one thing I just really encouragement. If you're on a security team and you haven't looked into honeypots or deception technology, I definitely encourage you to investigate it more. And obviously, honeydb.io gives you an opportunity to download and try it out and start tinkering with it. Yeah, because I really believe in our tagline, which is "Make your networks dangerous." And I think it really turns the tables if you for lack of a better term, litter your network with these sensors that intruders can trip over. It really gives you the advantage. And in those cases, the attacker is going to go somewhere else. Once they know that there's a honeypot on the network, they're going to pack up and they're going to go after the weaker target, right? They don't want to get burned, so they're going to move on. So it's definitely worth looking into. So I just encourage people to do that.
Awesome. That's a great call out. Thank you, Philip, for joining us and having this conversation. And I encourage our whole audience, if nothing else, just go set up one honeypot, see what it's like, put it on your home network and see if somebody scans it, what happens, right? Just have some fun with the technology, because that's half the fun of security. We get to tinker and have fun with cool and interesting technology. And at the end of our note, as always, remember, security is a journey, not a destination.